Welcome to the class. It's me, I Naganjanelu, JL in Chemistry, Aprjc, Nimmakuru. Okay, today we want to discuss lesson name is atomic structure. Atomic structure. From the 10th class, we know atom consists of three particles: electrons, protons, and neutrons. These are the fundamental particles of an atom. The fundamental particles of an atom is electrons, protons, and neutrons. Okay, these are the fundamental particles of an atom. Okay. Next, what about electron? Electron is represented by e to the power of minus 1 or beta, and it is discovered by J.J. Thomson. Charge of an electron is minus 1.6 into 10 to the power of minus 19 coulomb, or minus 4.8 into 10 to the power of minus 10 ESU. Mass of an electron is 9.1 into 10 to the power of minus 31 kg, or 9.1 into 10 to the power of minus 28 grams. In AMU, atomic mass units, it is represented as 0.000548 AMU. And charge by mass ratio means charge of electron is 1.6 into 10 to the power of minus 19 coulomb by mass. By this one, you can get this value. This value by this value, you can get the 1.76 into 10 to the power of 8 coulomb per gram. Okay. Next fundamental particle is proton. Proton means, what is the means of proton? Proton is ionized hydrogen atom. Ionized hydrogen atom. It is represented as H+. We know hydrogen atomic number is 1. It is represented by 1s1. Okay, means hydrogen contains one electron and one proton. One electron and one proton. If you remove one electron from hydrogen atom, you can get H+ ion. Okay, if you remove electron from hydrogen atom, you can get H+ ion. Okay, it means the H+ ion does not contain any electron. So it contains electrons are 0. It remains. It has one proton. Okay, that is the reason why it is represented as H+. H+ means proton. H+ means proton. Okay, why we are calling as H+ is a proton? Because H+ does not contain any electron. Okay, H+ does not contain any electron. Let us see here. Contains initially one electron, one proton. After removal of one electron, you can get the H+. H+ does not contain any electrons, so it contains only proton. So that is the reason why it is represented as proton. Okay, it is discovered by Goldstein. Next, charge of proton. Charge of proton is 1.6 into 10 to the power of minus 19 coulomb, or plus 4.8 into 10 to the power of minus 10 ESU. Next, mass of proton is 1.672 into 10 to the power of minus 27 kg, or 1.672 into 10 to the power of minus 24 grams. Charge by mass ratio is 1.6 into 10 to the power of minus 19. Mass of charge of proton here 1.6 into 10 to the power of minus 19. Mass of proton is 1.672 into 10 to the power of minus 28. This one by this one, you can get the charge by mass ratio 9.58 into 10 to the power of 8 coulomb per gram. Okay, next point, neutron. What is the means of neutron? Neutron is represented by 0 n all to the power of 1. It is discovered by James Chadwick. Okay, charge of neutron is 0. Okay, only the fundamental particle which does not contain any charge is neutron. Neutron does not contain any charge. Next, mass of a neutron is 1.675 into 10 whole to the power of minus 27 kg, or 1.675 into 10 to the power of minus 24 grams. In AMU, 1.00893 AMU. Okay, and then charge by mass ratio of neutron is 0. Why? Charge is 0. 0 by something. It contains mass. So something 0 by something, 0 by something leads to the 0. Okay, that is the reason why charge by mass ratio of a neutron is 0. Okay, why I am telling all those things? These points are very important to understand the intermediate chemistry, atomic structure in a better way. Okay, if you know the basic idea of what is the charge of an electron, what is the charge of proton, what is the mass of an electron, what is the charge by mass ratio, how do we calculate the charge by mass ratio of an electron or of a proton, of a neutron. So, what is the representation of an electron? What is the representation of proton? Why we are representing H plus for a proton, and how we can represent it as a neutron. Okay, these are the fundamental particles, and this is the introduction class for the atomic structure. Okay, introduction class for the atomic structure. Okay, atomic models, what it deals, the concept of atomic models, what it says is how the fundamental particles are present in an atom is explained by atomic models. Atomic models deals or says how the fundamental particles are present in an atom. Okay, there are two models now we are discussing. Okay, one is Thomson model. Okay, this is known as Thomson model. Okay, first one is J.J. Thomson model. J.J. Thomson. Okay, J.J. Thomson model. Model of an atom. Model of atom. According to Thomson, J.J. Thomson model of an atom, okay, this is also known as watermelon model. Watermelon or plum pudding model. Plum pudding model or watermelon model. Watermelon model. According to this model, the positive charge is uniformly distributed throughout the atom. The positive charge is uniformly distributed throughout the atom, and electrons are randomly distributed or embedded in this positive charge. Okay, this is watermelon model or plum pudding model. Okay, let us assume it is a watermelon model. Okay, the whole positive charge is distributed. The positive charge is wholly distributed all the area. Okay, it is not distributed in a particular area. It is positive charge is distributed all the area. of an atom. Okay, and the seeds are represented as electrons. Okay, the seeds are represented as electrons. These are randomly distributed. The seeds are randomly distributed. Okay, this is known as negative charge, and this one, okay, this one is known as positive charge. Okay, positive charge. Okay, negative charge and positive charge. Positive charge is distributed in an atom. Okay, we know all the atom is distributed by positive charge, and negative charge or negative charged particles are embedded. It means incorporated in an atom. Okay, like a watermelon. So the seeds are represented as an electron. The remaining part, the colored part, is indicated by positive charge. According to this model, we understand the charge and mass are uniformly distributed. These are not concentrated at any part. Okay, according to this theory, mass of an atom is uniformly distributed. According to this theory, the important point is mass of an atom is uniformly distributed. Okay. Mass of an atom is uniformly distributed. Okay. Mass of an atom is uniformly distributed. It is mass of an atom, not concentrated at any particular point, it is uniformly distributed. Okay. Electrostatic force, in the second point, electrostatic force, okay, is balanced. Electrostatic means there is a attraction between electrons and a positive charge is balanced. Okay, according to this 2 points they are mentioned. Mass of an atom is uniformly distributed. And electrostatic force of attraction is neutralized. Okay, this is the atomic model. One of the atomic model is introduced by J.J. Thomson model of an atom. Okay.